Hello everyone, myself Dr. Amit Kumar Yadav, Associate Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana. Today we are going to explore something fascinating, how AI make decision. This session is called Unlocking the Black Box and we will focus on features attribute method, which help us understand why AI models behave the way they go. What is features attribution? Imagine a detective solving a case. They examine fingerprint, witness statement, and motives, each clues pointing toward a conclusion. Features attribution does the same for AI. It reveals which input features the clue led the model to its prediction, the conclusion. It's open the black box. We can say that imagine a detective solving a case. They don't just jump to a conclusion. They example clue, fingerprint, movies, witness account. Features attribution work the same way. In AI, the clue are input features and conclusions the model's prediction. Our goal is to uncover which features influence the decision and how much. Why do we need to understand AI? Trust. Can we rely on AI in critical areas like healthcare or finance? Debugging. If something goes wrong, we need to know why. Fairness. Is the model biased toward certain inputs? Improvement. Understanding leads to better model. So we can say that explainability is not optional, it is essential. Features importance analysis, the big pictures view. Features importance. What's most influential? Think of baking bread. Some ingredients are absolutely crucial. Remove the flour and you have no bread. Others are minor. Skip a pinch of salt and it barely matters. Features importance tells us which input variable has the biggest overall impact on the model prediction, measured across many examples, not just one. How does it work? So, how do we measure importance? We do a simple experiment. Remove features, retain or evaluate the model. Observe how much the output change. If the model performance drops significantly, the feature is important. It's like removing flour from bread, everything falls apart. Predicting house price. Consider a model trained to predict house price using these features. High importance square footage location. Medium importance number of bedroom. Low importance age of house. In another word, we can say that We are predicting house price using features like square footage, location, bedroom, age of the house. Typically, square footage and location high importance, bedroom moderate importance, age often low importance. So not all features contribute equally. Visualization importance bar chart. Reading the chart, each bar represents a features. Longer bar is equal to higher importance. This chart make it immediately clear that square footage and location dominates the model's decisions while age of the house barely register. So we can say that bar charts are most common way to display feature importance. Limitations of features importance. Global view only. Features importance so that uh, matters overall. Averaged across all prediction. It misses the story of any single example. No direction. It doesn't tell us how a features influence a prediction. Is a large square footage always positive or only in certain neighborhood? Ignore interaction. Features often work together. Importance scores may miss subtle relationship between two features acting in combination. This is why we need a powerful tool intercept. In another word, we can say that feature importance has certain limitations. It gives only global view. It doesn't shows direction, positive or negative impact. It ignores interactions between features. So we need something more powerful, and that brings us to SAP. SAP, the fair share explanation. Introducing SAP. SAP stands for Shapley Additive Explanation. It is one of the most popular and mathematical rigorous method for explaining AI models prediction. It is rooted in game theory, specifically the concept of Shapley values, which were designed to fairly distribute payoff among players in a cooperative games. SAP bridges the gap between complex model behavior and human understandable explanation. The game theory analogy a team project, imaging a team of students collaborating on a project. They receive a single group grade. The question arises, how do you fairly give credit to each student? One team earn a grade, the whole team get one score together. Who contribute what? Each student contributed differentially. Fair credit distribution, SAP assign each member their fair shares. So, in another word, we can say that imaging a group project, the team gets one final grade, but who contribute what? SAP solve this by assigning fair credit to each participant in AI. The team features the grade prediction, SAP fair distribution of contributions. Safely values the core idea. Developed by Lord Shapley, a Nobel Prize winner in economics, Shapley values are built on a rigorous mathematical foundation. Consider all possible combination, collision of features. Calculate each feature's average marginal contribution across every collision. This guarantees fairness. No features get more or less credit than its teacher. Shapley values satisfy four key fairness properties: efficiency, symmetry, dummy, and additively. How SAP work for AI? Player, the features of your data, square footage, bedroom, location, etc. Game, the machine learning model making a prediction based on those features. Collision, a subset of features used as input to the model at a given moment. SAP value, the fair contribution of each features to the final prediction output. SAP local explanation. Unlike global feature important, which summarize behavior across all data, SAP explain each individual prediction. For a house priced at 450,000, SAP tells you exactly why this specific house received that price. Was it the large square footage, the great location? SAP break it down precisely. This is called local explanation, zooming into one prediction rather than overall prediction models. SAP summary plot the full pictures. It combines the best of both world, global and local insights in one view. Y-axis features ranked by overall importance. X-axis SAP value positive is equal to pushes prediction up, negative pushes it down. Color red is equal to high features value, blue is equal to low features value. This reveal not just what matter, but how and in what directions. So we can say that shape summary plot, it gives a visualization combining everything. Features ranked by importance. Impact shows on x-axis. Colors shows features value. So now we know what matters, how it affect prediction, and in which directions. Save force plot one prediction explain. Final prediction $450K model output. Base value $280K starting point. Few bedroom $5K negative effect. Large square footage $95K positive effect. Old age say $15K negative effect. Great location $75K positive effect. So we can say here the force plot zoom into a single prediction. Features pushing the value higher appear on the right, those pushing it lower on the left. The final prediction is where these forces balance out, making the AI reasoning fully visible. So say force plot, this is my favorite visualizations. It explains single prediction like a tug of war, featuring features pushing price to shown on one side, features pulling it down shown on the other. The final prediction is the balance of these forces. It makes AI reasoning almost visible. Features attribute method in action. Features important, best for quick overview of what matters most across the entire dataset. Simple, fast, and easy to interpret. Great as a first step in analysis. SAP value, best for details, fair explanation of individual prediction. Mathematically sound and highly expressive. The power of understanding. Features attribution may give AI a voice, the ability to explain its own reasoning in terms human can understand and act on. By applying this technique, we can build AI systems that are more trustworthy, fair, and improvable. Systems that earn their place in critical decisions. Understand, know which features give drive predictions, explain, communicate model behavior to stakeholder, improve, use insight to refine and strength. Any questions? Let's discuss how we can apply these methods in real world system. If you want something features importance, it means global view what matters most overall. Safely values fair credit distribution from game theories, SAP local and global explanations. Unboxing the AI black box, understanding how artificial intelligence make decision and why it matter for all of us. What insights the AI black box? Modern AI can make incredibly accurate prediction, but their inner working are often invisible, even to their creators. Today, we will explore the tool that leads peak insights. The problem AI is getting smarter but harder to understand. Imagine a super smart student who always gets the right answers but can't explain how. That's modern AI. When AI makes high stake decisions in medicines, finance, or law, we need more than a correct answer. We need regions. So we can say here nowadays AI make a correct answer, but we don't know how that answer is coming. We don't know what is say computational analysis, what is happening inside the AI models. Why do we need to understand AI? Trust. Would you trust a doctor who can't explain their diagnosis? AI must earn trust through transparency, fairness. Is the AI treating everyone equally? Hidden bias can lead to unfair outcome for real people. Improvement. We can only fix what we understand. Knowing how AI works lets us make it smarter and safer. So, so we can say here there are four key reasons why do we need to understand AI. First one, trust. Can we rely on AI in critical areas like healthcare or finance? Debugging. If someone if something goes wrong, we need to know how why. Fairness is the model biased towards certain inputs. Improvements, understanding leads to better model. So explainability is not optional, it's essential. Introducing explainable AI, XAI acts like seed translator for AI, converting, say, complex machine decisions into language human can understand. In spite of just answering, explainable AI provide reasoning, making AI system more accountable, trustworthy, and transparent. Lime, the local detective. LIME stands for Local Interpretable Model Agnostic Explanation. Think LIME as a, say, detective who focus on one specific case, one AI prediction at a time, rather than trying to understand the entire AI. It zoom in on a single decision and explain what drove that outcome. How Lime work? A simple analogy. Complex AI model, Lime zoom it, simple local models. Imagine a complex maps having so many features and it represent AI model. What Lime does here, it zoom in on one specific spot, a single prediction, and it draw a simpler local map around it. The simple local map is easy to read and it tell you exactly what's happening right there. Even the full map is too complex. Lime in action tabular data. For tabular based data like customer record, Lime slightly tweak the data around a specific prediction and it watches how the AI responds. Features that cause the biggest changes are flagged as most important. For example, why was this loan application approved? Here, Lime predict income level and credit score. So this is two decisive factors. Liming action text data. Here how it works. Lime remove words from a text one by one, watching how the AI's predictions shift. Words that cause big change are marked as highly influential. Example, why was this email flagged as spam? Lime highlights words like urgent, free, and click here as the culprit. Lime the big pictures. Local, it explains one predictions at one time. It doesn't explain whole model at once. When we consider interpretable model, it utilized simple model like linear regression that are easy to understand for human being. Model agnostic work with any AI model from decision tree to deep neural networks. Integrated gradient tracing the path. Integrated gradient nomenclature as IZ is an explainable AI techniques that trace the exact path of influence from input data all the way to final prediction. It is just like imaging uh, flowing like a river from a source to the sea. Source here represent in this figure is a mountain, and here final stage is the sea. So we can correlate this integrated gradient tracing the path. How integrated gradient work? Try to see here the river analogy. Think for a time being, imaging AI as river. Integrated gradient measures how much each section of the river bed input feature shapes the water flows the prediction. Here it compares the final prediction against a baseline an empty riverbed and calculates how each features contribute to the difference step by steps. So we can say that it works in just like say uh, a river. Now integrated gradient visualizing importance. Integrated gradients it assigns say different score to each input features. Here features means input variables. The higher the score, the more the features influence the final uh, predictions. For example, take an image classification as cat. Integrated gradient might assign high scores to pointy ears, this one. Pointy ears and whiskers, this one. The features that matter most. So we can say that these integrated gradients are used for say features selections. Integrated gradient strength. What it does? It provides clear attribution. It precisely shows which input drove the output with no guesswork, and it acts as mathematical foundation grounded in calculus, satisfying the completeness axiom for reliable attribution. Deep learning ready. especially powerful for complex neural network where other method struggles. Deep lift finding the important features. Here deep lead means deep learning important features. Its purpose built to explain decisions made by deep neural networks. And this deep neural network, it is called as most complex AI system which we are using in today world. Deep lift doesn't just look at a final output. It traces influence through every layers of the networks. How deep lift work together comparing to a baseline. Try to see here this baseline. Here we are having this actual, then here deep lift. Deep lift, when we compare the network's actual output to what it would have predicted with neural baseline inputs. The two reveals exactly on how each features contributed positively or negatively to the final decisions. Deep lift focus on contributions. Deep lift assigns contributed scores to every neurons and connections in the networks. It reveals which part of the AI are doing the most work for any predictions. Like identify which specific gears are turning hardest inside the complex machines. Line versus integrated gradient versus deep lift. Line, it explained locally by fitting simple models around one prediction. It works with any AI models. It is best for general purpose explanation. Integrated gradient. What it means? It is the path of influence from input to output using calculus. It is ideal for deep learning with strong mathematical guarantees. Deep lift compared to baseline to assign contribution scores neurons by neurons, also designed for deep neural networks. The future is understandable AI. Now we see here as AI become more powerful and it is embedded in critical decisions. Explainability is no longer optional. It is essential. So what we can say here, explainable from AI is essential nowadays as AI is growing. Line, integrated gradient and deep lift are the building blocks of trustworthy, fair and accountable AI system for everyone. Now, so what we have studied today is Lime, what it means, try and explaining a simple AI prediction using the local perturbation approach. Explore integrated gradient. Apply IZ to an image classifier and visualize which pixel matter most. Dive into deep lift. Use deep lift to trace contribution score through a neural network layer by layer. Therefore, keep learning explainable AI, which is a fast growing field. That's all. Thank you.